Alright guys, this is the unit on measurement. We're talking about the metric system. You had this slide last week, and you were supposed to have taken this document and filled in notes from these slides, and the things in red are what you're supposed to have filled in. So let's talk about these. First off, the red countries, USA, Liberia, and Burma, are the only countries that don't use the metric system. Thoughts on that? You're supposed to have taken those ideas and recorded them right here, where it says record your thoughts about the red countries that do not use the metric system, and typed answers here. Most students are surprised to learn that the metric system is so widely used. Metric system meaning meters, centimeters, liters, like your soda bottles, grams, things like that. The three countries, the USA, Liberia, and Burma, are the only countries left that still use like ounces and pounds and things like that. So, the metric system. We're talking about that because the standard or customary system is only used by the United States and 2 other countries. Okay, that is not the definition for a metric system. So on your paper, metric system definition, which several of you missed right here, is found right here. The metric system is a standard unit of measurement based on the number 10. So if I take that measurement system based on the number 10, and you're going to put that here. Measurement system based on the unit. Is that what it said? Based on the number 10. Number 10. Okay. So what we're noticing is that every time I go up in the metric system, I add a 0, and every time I go down, I subtract a 0, and I realize, yes, there's a 0 that's added here. What we're looking at is the fact that it's getting smaller and smaller. So let's talk about length. Length is a distance from one point to another. Okay, so the definition for length, where it says type definition, distance from one point to another, should be here. And the base unit of measurement in the metric system, metric base for unit, is the meter. So I would go back over here and I would write meter, and the tool used, I noticed, said ruler. So type ruler. You can delete these extra lines if you want. The base unit of measurement in standard is going to be inches, so you would have put inches over here. And the tool used would be a ruler. Again, so we're using rulers still. The difference is the scale that the ruler is on, centimeters versus inches. This particular ruler is a meter stick, and it has centimeters on it. And then millimeters are going to be the little guys in between. Now remember, we said that it was based on the unit of 10. So if you count the little lines in here, there's actually 10 lines. Each little line is a millimeter. If I go back to my scale, centimeters to millimeters is one little jump of 0, one jump of 10. So there's 10 millimeters in a centimeter. There's 10 centimeters in a decimeter. There's 10 decimeters in a meter. Okay, so let's keep going. If I'm taking mass, mass is a measure of the amount of matter in an object, and you could actually copy paste here. I'm going to paste without formatting so that it doesn't get all crazy big. Okay. So the metric unit is going to be grams, and the tool used is going to be a balance. And we're talking about slugs for standard. Now, you've probably never heard of a slug, okay? Well, not the gross, wormy, buggy thing that crawls on the ground. A slug in measurement is the unit of mass. Mass is a measure of the amount of material or matter inside the object. When I get to gravity here, we know our mass is 100 kilograms, whether I'm on the Earth or on the moon, because when I take my astronaut and I go from the Earth to the moon, the amount of material inside of his body has stayed the same. His weight, however, is going to be dependent on gravity. So weight is a measure of gravity pushing down on an object. So when I talk about my weight on Earth, when I say how much do you weigh, I'm referring it to the gravity affecting your body. If I went to Jupiter, I would not weigh the same. So if we're talking about weight in metric, that's newtons. And you'll talk about that when you get to physics class, probably in high school. Okay, so we're not going to talk about that too much here. So what I mean by weight, okay, so let's say that I weigh 120 pounds on Earth. Okay, I would multiply my weight by 1. So again, which makes sense because on Earth I'm still weighing 120 pounds. In outer space, there is no gravity, so I'm not going to weigh anything. 120 times 0 is 0. If I go to Venus, though, and I weigh 120 pounds on Earth, my weight on Earth, I would multiply this by 0.90. And if I grab a calculator here, so 120 times 0.90, I'd be 108 pounds. Notice that my weight has decreased because the amount of gravity on Venus is less. I'm going to not do all of these, but I'm going to jump to Jupiter. 120 times 2.36. 283.2. Now, it's important to note that just because the weight is increasing across from Earth to Jupiter, that's just because there's more gravity. The amount of material inside of my body has stayed exactly the same. Okay? So slugs deal with mass on Earth, or excuse me, in the United States, because that's how much the material is inside of this piece of fruit or whatever the word is we're looking at. Or we're talking about grams, okay? Weight, pounds, has to do with gravity. But moving on to volume, the measure of how much space it takes up. So some of you remembered that all matter takes up space. Okay, so, oops, did that wrong. I paste without shoot, come on. Paste without formatting. How much space it takes up. Okay, so the base unit of measurement in metric system is liters. Think about your soda bottles. When you buy soda, okay, it's typically going to be in liters. Anybody know why it's going to be in liters? Where does Coca-Cola sell their products? Is it just the United States, or is it everywhere else? Everywhere else uses metric, so it makes sense that those companies are going to want to appeal to the other countries too. So I'll show you a graduated cylinder in a second, but the tool we're going to use is a graduated cylinder to measure it, and then we're going to be using gallons for volume, and you guys know that when you buy milk, it's in a gallon. Try to get rid of these extra spaces here. Oh shoot, not that. Go away. Still not working. Okay, whatever. I give up. All right. Measuring cups. You guys have all used measuring cups before. Okay? When you're making a cake or anything, or you're trying to measure out stuff in the kitchen, you use measuring cups. All right. So half a cup, third of a cup, anything like that. All right. So I'm still talking about volume. If I'm in math class, and you guys have done this before, length times width times height, if I have a very nice, pretty box that has very straight sides, I can take all these measurements and multiply them together, and I'm going to get 56. That's fine. However, there are lots of objects like a remote control or a stapler or this little guy here that looks super cute. I can't really do length times width times height because there's so many weird sides. So what you have to do is get a known volume of water, drop him in. This is a graduated cylinder. You're going to hopefully practice with this tomorrow. And you're going to measure the difference here. So I read the bottom of the meniscus. The meniscus is the curved line. So from 3 to 4, if I go 1, 2, 3, 4, it's 5 spaces. So every space is worth 2. Remember, because I said it's a difference of 10 in between each one. So it's 3.2, 3.4 milliliters here. But then when I drop him in, okay, it goes up to 5. So if I do 5 minus 3.4, you get 1.6. So the little guy measures 1.6 milliliters without having to actually have dropped him in. You'll be practicing with that. Temperature, the basic is the measure of the degree or intensity of heat present. And again, we're going to paste without formatting. And we're going to measure in metric. We're going to be using Celsius. Okay, now Celsius is a guy, so they used his name to make the base unit of measurement here. The tool used, you guys know, is going to be a thermometer. We're using thermometers in both. Okay, and the base unit here is going to be Fahrenheit. Okay, I didn't put that on here very well. Fahrenheit over here on the right, that is the other guy that uses this standard system. So I'm just going to abbreviate it F. So degrees Celsius with a C or degrees Fahrenheit with an F. And we're both using thermometers, it's just a different scale. Water boils at different places on different scales. Now, water is still water. Water boils when it boils all the time. It just depends on how you're measuring it. So if you're measuring in Celsius, 0 degrees is freezing when it turns into ice cubes, and 100 degrees is boiling when it starts to boil and make your pasta or your macaroni and cheese. If I'm in Fahrenheit, it's going to measure at, or excuse me, turn to ice cubes at 32 degrees and then turn to boiling water for your pasta, your macaroni and cheese, your noodles, whatever you're making, at 212 degrees Fahrenheit. But again, it's going to boil no matter like when it's hot enough. It's just a matter of what scale you're using to measure that. Okay, I kind of jumped the gun here. There's Fahrenheit. All right, density. Now we're taking density and we're actually getting a ratio, out of the mass and the volume. You're going to divide them. You're going to do the mass divided by the volume. It is a math problem. So just mass, meaning you could have, if I grabbed like, I don't know, paper clips. I could grab a whole bunch of paper clips, the mass would be huge. But the density is going to be the same because when I take the mass divided by the volume, I'm always going to get the same ratio for each specific object. So paper clips always have the same density as every other paper clip. Sugar has the same density all the time, no matter how much sugar you have. The amount may change, the volume may change, but when you divide the two numbers, you're going to get the same thing. So the formula, when you're supposed to put it in, some of you got just put in the really big formula, make it smaller. All right, and then we'll practice with density over the next couple days. All right, so here's what I mean. I could have two very similar sized objects, a volleyball and a bowling ball. Really super pretty here. If I crack a bowling ball open, okay, it's very solid on the inside. So even though these objects are the same, one might be solid on the inside, but when I could open a volleyball, it's not. It's full of air. Okay, and actually, this is a YouTube video I found where somebody actually cut it open for his kids. You can click on the video and watch it if you would like. So density takes into account how much is inside of the object, even if it's the same size. Okay, so that's what the division problem is for. Time, there's not really a definition. It's kind of an abstract concept, but there's not really a definition here. Why I did that? I'm sorry, guys. Seconds. Okay, we use seconds all over the world. That's kind of straightforward. Okay. So that's the measurement lesson. I want you to think about any questions that you have, and please let me know. Oh my God.